Today, we're going to be doing this duplicate curve system with these points to have the points follow the spline curve as we're kind of moving them through. We're going to use a few different techniques to make it happen. We're going to be using duplicate elements, a set position to kind of displace them, as well as a for each element to make sure we have each of these curves have an actual point following it. Let's jump right in. So first, we're going to delete the cube and we're going to add in a curve Bezier circle. This is what's going to hold the system. So we're going to do a new geometry node system right there. We're going to zoom in a little bit and we're going to look at this. So the first thing we're going to do is we're going to duplicate the elements. We're going to add a bunch more splines. Let's do like 10. So now we have 10 of them. So you can see right here, it's 10, which is nice. And then to see all of them, we're going to displace them. So we do a set position to displace, and we can do a noise texture to make it really easy to see. So like this, you plug in this into the scale, but probably better to do 4D and put that into the W. We then kind of have it all going as like separate spots. But I want it to be kind of like going around like in a radius. So we can have the main like curve and everything's around it in a radius. So it's kind of however you want it. I think that's kind of more fun to have it that way. So how can we do that? We use, instead of a noise texture going right into the offset, we can use a vector rotate instead. So vector rotate, we're gonna plug that in. And then what we're gonna do is we're gonna put it on two things. We're gonna do a normal, and that's gonna be the vector. And we're gonna do the curve tangent, which is right there. And to move it all the way around, as you can see, it's rotating and following it around a little bit, which is good. We wanna see that. What we're gonna do instead is we're gonna use this noise texture with the angle. So if it's like that, we're splitting it out a little bit, but to do it even better, we can just take this and add it into the overall scale of the noise. So we're gonna do a math. We're gonna add this, cutting that here. And then what we're getting is we're getting all this noise piping through. And then we're gonna take this actually before it, we're gonna add a 1. That way, because you know for this index, it's going from 0, 1, 2, 3, right? And so for us to have it like scale correctly, we don't want to have it be at 1. We want to add 1 to it. So it'd be like 1, 2, 3, whatever. So it adds 1 even to the 0th index, right? And if we multiply this, we can see all of them are moving. If this is here, I think it actually make 1 not move. I guess 1, actually, they're all moving. Never mind. I guess this actually doesn't matter. Just kidding. So it would just be if we did this, right? What I was talking about is if we just did this, if we said add 0 and then we multiply. See how this one right here is not moving? If we add 1 to it, then they're all moving around together. So that's kind of the main thinking. But since we're adding in the noise right here, it's fine. Actually, 1 is moving slower than the rest, as we can see like right there, right? If we were to add in a 1 beforehand, yeah, then I guess they're all moving at different rates because of the index anyway, but it's fine. I think it looks better that way. So then the question is how much we multiply it. It doesn't really matter. I guess we could just see what's a number that looks reasonable for getting it to go. It looks like it's probably some multiple of pi, right? So if we take this, we do a divide, we do an integer here, we have 10 of them, and we have this going here, 10. Will this work? We do this, it said pi, tau. Yeah, I think that then makes it like split evenly. Nice. And so then if we change this noise here, we're getting a little bit happening. So let's resample the curve. So resample curves, add more resolution, resample curve, and we're at length, and now we're getting that. Nice. So then I would just make the scale a bit bigger, and now they're all going around. They're a bit wobbly, which is nice. And then what we want to do is also nice. I just increased the resolution a bunch. And I think this back spot is really multiplying it out because of the, it's because of the duplicate index on the, let me see what we should do is this. This is probably gonna be better. No, it's not the W cut there. I think that's actually better. And then if we take this and we multiply it by like 0.5, if we add 1 and then multiply by 0.5, that way everything multiplied going through. And the scale on each of them is close enough. And then this can still impact the scale of everything. Then these endpoints are curling so much. Why is that? Oh, I cut this. There we go. That's coming in together, and we want to do the rotation still. So then let's do here, multiply, add. Nice. And so then in order to have this isn't even needed. Yeah. So we're having this noise come in, and then we're multiplying it with this to make sure the radians work out. So we're dividing the number of splines being duplicated by tau. So it's going to be 2 pi for the 360 rotation. And we're using the index on 2 spots in order to make sure we have this kind of coming through. The index is also being added into here. So we have all this kind of splitting across, which makes it look good. This is off. It's not going to go all the way. We got to pipe it in again. So that's looking pretty cool. And so then we have this to drive the W value here. And then we also have, I think if we do add here, if this add here, we have this to drive the rotation of everything. So we can put it at 0 for now, and it's looking okay. So now we have some noise in those curves themselves. And then we also want to do is change the scaling of this so it works a bit better. So if we do another scale node here, and then we do a float curve, I should do it first right there. And then let's just plug in a number that makes sense. We have all of this coming through. And then what we're going to use is a spline parameter using that factor. And now we have at the start coming through, and that can kind of make these look good. So now it's coming through, it's expanding out as it goes through, which makes it look nice. Nice, happy with it. So then now that we have this, now the overall like splines are looking okay. And then what we should also do is take the main spline, we're gonna have the main point go through, is also join that in. So if we do a join geometry, take in this with a reroute. First, we go reroute, plug it in there. We're then having that center spline as well moving through. That center spline is not distorted. Noise texture, just plug it in there. And the endpoints need to stay the same. So do endpoint selection. What happens if I just do it all in this? Let's just see actually. Yeah, it's gonna be rotated out, so we can't do that. Yep, makes sense. So that's the case. It's still this endpoint selection, not those guys. Pull back the scale a little bit, and then we can do a math node. Plug it in here, 0.1, multiply. Nice. So even that main one is also squiggly. All of that curve data coming through looks cool. It's expanding out. And now what we can do is we can then do the for each element. That's how we're gonna get the points. That's coming in here, gonna be splines. And on each spline, what are we gonna do? We're gonna do a spline or sample curve of each spline to get those positions of what? So a set position of this position into a what point? And it's going to be this point coming through. And then the index of it is on all of them, all of those curves. And the issue is these points are too big. As we increase the factor, we can see all of those points coming out and then following the Bezier curve. That's pretty cool. So if we take this, we do a join geometry, do this, you're now going to see those points follow along the factor of it, right? So we're almost done. And we want to instance something on those points. And so as we're going through, we want to make sure we have something. So let's try this. Instance on points, and we're going to instance a cone. And let's do a transform geometry. Make the scale much smaller. And then let's capture attribute. Let's do curve, tangent, align, rotation to vector. Do this guy, plug this in. It's looking pretty good. It's looking like it's flowing as we would expect. So now the beauty of this system is we can take all of this, subdivide, add an extra point, pull it up, make it look weird, let's scale it out, grab this down, extrude it out, another one. So now let's see how it follows. It's close, but it's not following along the perfect part of it. It's only doing the initial sample. So I think what we need to do is do it as it's moving through. So if we actually take this as a vector, plug it out, plug it into here, will it work? Let's see. We're getting something. Pointing around, let's see how, yes, now it's working. So for each spline ID, as it's moving across on the factor, we are sampling a new curve tangent. Nice. That is the answer right there. That's going through. Nice. So what if we want to have like a cool flip or something of these these instance shapes? Rotate instances, that's the answer. The Z will just spin them, the X will do along there, and then the Y will go this way for the flip. So let's say you want it to flip as it's going. What it should do the flips here after you do the instance on points with the vector. Nice. I think it's pretty cool. So then we can do whatever we want, and that's kind of the main effect. Nice. So then basically all we need to do is finish setting the scene and rendering it out. Hope you guys learned something, and I hope you guys enjoyed it. The project file will be on my Patreon for free like always.
Augury.